Okay, so in our last class, we discussed about protection, more particularly N protection. So N protection is also called as amino protection. So there are three groups, more particularly benzyl oxycarbonyl group. So benzyl oxycarbonyl group is called Z group. Okay, how the protection means how the preparation of benzyl oxycarbonyl group, and then what is called as how it is protected to the amino compound, and how after once the desired peptide is synthesized, how it is deprotected. Okay, and this benzyl oxycarbonyl group is sensitive to the acidic, and acidic conditions can be used to cleave the N protecting group, that's called benzyl oxycarbonyl group. So one more N protecting amino group is called butyl oxycarbonyl group. This butyl oxycarbonyl group is prepared, and how the prepared one is used for the protection of amino group. And this butyl oxycarbonyl group again is also sensitive to the acidic condition, and one can use acidic condition to uh, cleave the N protection. And one more is what is called as a N protecting group is called F-mark group. So how the F-mark group is prepared, and how it is uh, uh, protected to the amino acid, and how it is deprotected. So once the desired peptide is obtained. So deprotection for this F-mark group is mild organic base is used. Mild organic base may be a what is called as a pyrrolidine, okay, piperidine, okay, or pyridine, or these kind of organic bases are used to deprotect the F-mark group of the peptide. Okay, so these are all the three methods of amino protection of uh, uh, amino group. So why we need to protect to in order to make a interaction between the amino group of the one carboxylic acid and carboxylic group of the another amino acid, we need to protect amino group. So then only it is possible. Otherwise, what will happen? Otherwise, we may end up with the undesired products. Okay. So, for example, in the case of glycyl alanine, so if we are not protected, it is also possible to form a glycyl glycine as the unwanted product. So that is the reason N protection is required. Also we discussed about advantages of protection, and also we discussed what is the protecting agent, okay, how it could be, and what are the criteria. So more particularly means it should be introduced easily, and it should inert during the peptide synthesis, and it should not interact, okay, uh, and it should be cleaved under mild conditions. These are the characteristics of the protective group. So now we know that the N protection. So similarly, we also require to do a C protection. Okay, so if you are protecting C, I mean C protecting, then you can build the peptides from the amino end of the amino acid. If you are protecting amino group, then you are synthesizing the peptide from left hand side N terminal end to C terminal end. If you want to prepare a peptide starting with the C-terminal end to N-terminal end, then C protection is required. So here there are many C protecting agents. So one of the commonly used method is converting into a ester. So maybe there are, for converting into a ester, so one can use a simple. I think you are aware about the esterification. So esterification means what is called as converting a amino carboxylic acid into ester. So for that one can use methanol, ethanol, propanol, butanol. So these are common esters. And special esters means benzyl. Okay, benzyl is a special ester, special alcohol, and this can be used to convert acid into ester. Similarly, one can also use a tertiary butyl group to convert amino acid into a ester. So, and once the protection is over, protection, C protection means it's nothing but a conversion of amino acid into ester. So how you can do? By esterification method. What is esterification? Treat the amino acid with alcohol in presence of acid. Acid may be a sulfuric acid, one drop. Okay, otherwise PTSA. PTSA means para-toluene sulfonic acid, and one more maybe a thionyl chloride. Yeah, maybe anhydrous hydrogen chloride. Okay, so these are the methods you can convert into a ester. So if you are taking methanol, amino acid will convert it into methyl ester. If you are taking ethanol, amino acid will convert it into ethyl ester. If you are taking benzyl alcohol, it will be converting into a benzyl ester. If you are taking tertiary butanol, it will convert into a tertiary butanol. So these are the methods. But when you are doing a tertiary butanol, so tertiary butanol is sensitive to sulfuric acid. So when you are adding one drop of sulfuric acid to the tertiary butanol, so what you will get? You will end up with a isobutene. Isobutene is the fragrance. The when you are opening a LPG gas, no, that fragrance is nothing but a isobutene. Right. So if you want to deprotect, so deprotection is called the cleavage condition. So common esters. So common ester by making with methyl, ethyl groups. So methyl and ethyl groups are easily removed, but by saponification process. What is saponification process? Treating treating an ester with aqueous alkali organic solvent. That means potassium hydroxide in alcohol. So that is an a saponification reagent. So what will happen, since there is a base contained in this, there is a possibility of racemization. So what is racemization? Racemization means if you are starting with the L amino acid, you may end up with the D amino acid. So you know that L amino acids are physiologically active. When the L is converted into D, then it is not active in the living system. Then that is a problem. So that is the reason converting a amino acid into a simple ester that may lead to the problem called racemization. So that is the reason it is possible to convert into a special esters called benzyl ester. So these benzyl ester can be cleaved by using hydrogenation. So benzyl ester can be cleaved by using hydrogenation. So hydrogenation means hydrogen in presence of catalyst. The catalyst may be a palladium or generally used one is palladium. So one can use the others also, other metals also. Then it is also possible to convert into a special ester called tertiary butyl ester. So this tertiary butyl ester also can be cleaved by using anhydrous trifluoroacetic acid. This is again mild acid. Okay. or with dry hydrogen chloride. So this is about a general information about the protection of carboxylic group and the deprotection condition for the uh, uh, C protected one. Okay, so normally write a note on C protection during the peptide synthesis. Then you have to write. Otherwise, write a note on carboxylic group. Then you have to write. So not only with this slide, I will also take few example of preparation and then deprotection of C terminal end. Okay, so in the next slide I will take examples. Okay, more particularly C protection examples. So protection using a simple alcohol. So this is one amino acid, and here we want to protect the carboxylic group. So if you want to protect the carboxylic group, one can take a methanol. So this methanol, when it is treated with H plus, so H plus source may be a dry HCl, H plus source may be a 1 or 2 drops of sulfuric acid, H plus source may be a para-toluene sulfonic acid. So what will happen? OH and H, removal of water, forming a ester. Now the carboxylic group is protected. And afterwards what you can do? So this free amino acid can react with one more amino acid, activated amino acid, to form a dipeptide. And that is again treated with one more activated amino acid to get a tripeptide. So until getting a desired peptide. Once the desired peptide is obtained, then you can cleave the C-terminal end. So it's called a deprotection. How you can cleave? By using 1 normal sodium hydroxide. So 1 normal means it is a dilute one. Okay, then what will happen? This was cleaved, means ester was converted into carboxylic acid. Now the free C terminal peptide is obtained. So this is about the protection of C terminal, means carboxylic group with methanol, and the deprotection with 1 normal NaOH. So this is about one example of carboxylic acid protection and deprotection. So with this, I will go to the next slide. Next, I am taking one more example. Okay, let's give an entry. Right. Okay, here what is happening? Uh, right. So here benzyl chloride. So what is benzyl chloride? C6H5CH2Cl. Okay. C6H5CH2Cl is called benzyl chloride. So this benzyl chloride, when it is treated with carboxylic acid, so what is going out? H and Cl is going out. So here, a base is required. So in presence of base, it is possible to convert amino acid into what is called C protected, benzoyl protected amino ester. So now the C is protected, means carboxylic end is protected by using a benzyl group. So benzyl group means C6H5CH2 is called benzyl group. Then okay, so if you want to deprotect, okay, of course, what you can do, okay, small thing. Okay, here I am taken N protected one. Uh, so of course, maybe this you can take free also. If you are taking a free one, then there is a possibility of reaction of this nitrogen with the this benzyl group. So that is the reason a protected one is required to do a C protection with the benzyl chloride. Okay. Then afterwards, after forming a C protection, what you can do? Cleave this N protected one treat with the required amino acid to get a di or tri or polypeptide. Once the desired peptide is obtained, then you can go for the deprotection of carboxylic end. How you can do? Maybe by treating with hydrogenation in presence of palladium, or maybe treating with hydrogen iodide, or maybe treating with HBr. So what will happen here? H minus will attack this carbon, converting into toluene. Okay, and then this can picks up a proton, means H minus and H plus. Okay, so overall H will add to, one H will add to this carbon, another H will add to bond with the oxygen. So that is how a compound is obtained. And in this process, the byproduct is toluene is the byproduct. Of course, here I mentioned the what is called as benzyl alcohol. So benzyl alcohol is possible when you are taking a HI. So HI, when you are taking HI, also benzyl alcohol is not possible, because benzyl bromide, benzyl iodide will be the uh, byproduct. Okay, so don't consider this OH. You make it as a CH3. That will be the better one when you are taking, when you are treating with hydrogenation in presence of palladium. This is about how a amino acid is converted into benzyl ester, and once the desired peptide is obtained, how the benzyl ester is cleaved or deprotected using a deprotecting reagents. So these are deprotecting reagent, and this is here in presence of base, it is possible to convert in acid into ester. So this is about one more example of C protection. So I will also go to the next slide. Next slide will give you the one more example of C protection and D protection. One, it's called, say, look here. So here benzyl alcohol used. Okay, instead of benzyl chloride, one can also use an alcohol. So here what should be removed? OH and H should be removed to get a ester. So in this case, the acid used one is PTSA. PTSA means para-toluene sulfonic acid. Okay, and MW means microwave condition. So this is not the regular room temperature reaction. It is a microwave condition. So I think you are aware about the microwave. Maybe I think, okay, I think in your second semester, one green synthesis is there, no? So there microwave condition, microwave reaction, microwave application about the traditional organic synthesis. Okay, it's called a special techniques in organic synthesis. Okay, so what will happen? Mixing these two, okay, putting into a microwave for a few minutes. Okay, in 5 minutes, maximum 5 minutes. Within that, the reaction proceeds and form a ester. So once this ester is obtained, then you can cleave this N protection, treat with the required amino acid to get a desired peptide. So once the desired peptide is obtained, if you want to cleave the C-terminal end, means C protection, then you can go for a hydrogenation in presence of palladium, or treating with hydrogen iodide, or treating with HBr. Okay, so what will happen? So there will be a cleavage here. Okay, this carbon is converted into CH3, and this there will be a bond formation between this oxygen and proton. That is how free C-terminal amino acid is obtained and the byproducts. This is about one more example when you are taking a benzyl alcohol as the reagent for the C protection of amino acid. So with this, I will go to the next slide. So next slide, I will explain about one more C-terminal protection, how the C-terminal is protected and how it is deprotected. So that I am taking isobutene. I think you know that this is the isobutene. So isobutene means the fragrance is obtained when you are opening a gas in a kitchen. Okay, that's fragrance is nothing but a isobutane. How the isobutane is obtained? So maybe of course it is present in, it is the byproduct of coal. And another one, if we are taking tertiary butanol and add 1 drop of uh, sulfuric acid, whatever the fumes you are getting, no, that fumes is nothing but a isobutane. So isobutene, and one more thing, isobutene is a gas, and this is a solid or liquid. So that means here heterogeneous reaction. So, and since there is an involvement of gas, then reaction should be carried out in a closed apparatus. So that is the condition for this reaction. So what is happening in presence of sulfuric acid? So there will be the lone pair or the bond pair can react with this carbon. Okay, and this bond pair can picks up a proton. So proton source is the sulfuric acid. So the obtained one is called, this group is called tertiary butyl group, and this is oxy. Tertiary butyl ester of amino acid. So now the amino C-terminal end is protected. So what you can do, you can cleave this N-terminal end and treat with the required amino acid to get a di or tri or penta or poly or yes, polypeptide. Once the desired polypeptide is obtained, then you can cleave this C-terminal end. That's called deprotection. So deprotection, it is possible with the trifluoroacetic acid. So what is trifluoroacetic acid? CF3 COOH is called trifluoroacetic acid. So trifluoroacetic acid is the stronger acid compared to the other one because of the uh, fluoro group is there. No, fluoro is the electron withdrawing group. So that is the reason protons are proton present CH3COOH OH proton is there. No? That is highly acidic and it is freely available. So when it is freely available, lone pair present on this oxygen picks up the proton present in a trifluoroacetic acid. What will happen? There will be a cleavage here. So when it is quenched with water, OH is attacking here, and this will one more proton from here. Okay, so coming over here, this will go out. Means here the byproducts are trifluoroacetic acid, water. Okay, and isobutene is another byproduct. Isobutene is a gas; it will go out. So this is about sea protection, how the sea protection is made, and how the sea protection is deprotected. So just I will summarize this sea protection. So simple alcohols can be converted, say using simple alcohol, carboxylic acids can be converted into ester. Those esters, when it is during the deprotection, if we are using a 1 normal NaOH alkali medium, so there is a possibility of racemization. So that is the reason it is advised or required to convert a carboxylic acid into special ester by using a benzyl alcohol or tertiary isobutene. So when you are using a benzyl alcohol, the carboxylic end is converted into benzyl ester. The benzyl ester one can be what is called as uh, 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 deprotected by using different conditions called hydrogenation in presence of catalyst. So during the hydrogenation in catalyst, it is possible to cleave uh, uh, a benzyl group into a toluene as the byproduct. So, and it is also possible to use a benzyl alcohol itself. Benzyl alcohol in presence of carboxylic end. So, in presence of a dehydrating agent, it is possible to convert carboxylic end into benzyl ester. Once the desired peptide is obtained, that can be cleaved by using a, deprotecting reagents called hydrogenation in presence of catalyst, and then hydroiodic acid or HBr or trifluoroacetic acid. Then isobutane itself is used to protect the carboxylic acid. A tertiary butoxide is obtained. Once the desired peptide is obtained, a C deprotection can be done by using trifluoroacetic acid. So what it will do is it will act as a source of proton. The lone pair present on this oxygen can react with that, and there will be a formation of OH. Then what will happen? There will be a cleavage. This bond is cleavage and forming a isobutene. So this is about the C protection and uh, uh, deprotecting reagents for the C protection. Suppose if there is a question on write a note on C protection, then you can write all these things. So up to this. And with this, I will go to the next concept. It's called methods, okay, or reagents used for the peptide bond formation. So methods are reagents used for the peptide bond formation. So look here in this slide, I'm explaining about the methods or reagents used in peptide bond formation. So one is acid halides. Acid halide method is this method was the first method reported by Emil Fischer. Emil Fischer is the father of carbohydrate chemistry or peptide chemistry. So what he done a 18 amino acid residue containing a peptide. He is the first person who is reported a peptide having 18 amino acid residue. So for that method, he is employed a acid halide method. That is one method. Using this method, one can prepare a peptide. Another method is called anhydride method. Using anhydride, one can prepare a peptide. So one more method is called active ester method. I will explain detail when I am taking individual reagent or method for the peptide bond formation. So active ester, it is another method for the peptide bond formation. So DCC method, here the DCC is the reagent. It is used, it is also called as coupling reagent. So you know that peptide, how it is formed. So peptide bond formation involves a 4-step. So what are the 4 steps? What is called as protection, activation, coupling, and deprotection. Okay, 4 steps are involved. So this DCC is the coupling agent. Okay, so okay, anyway, I will explain in a later slide. EDQ is another reagent. It is used for used as a coupling agent, and uh, uh, using by this reagent, one can achieve the peptide bond formation. HOBT method. HOBT is the reagent used for the peptide bond formation. So these are the different methods available for the peptide bond formation. Suppose if there is a question, give 2 methods of preparation of peptide bond formation. So then you can take any 2 from this 6, but you have to go for a detail, okay, how the N protected one amine is treated with the reagent and how it is peptide is formed. Detail one you have to explain. So now in the next slide, I am taking acid halide method for the peptide bond formation. So this is the one. So here, what are the different methods for the formation of peptide bond? So one can frame question on this 6 methods. Sometimes they will ask you directly. So what is DCC? Okay, how it is useful in the peptide bond formation? What is HOBT? How it is useful in the peptide bond formation? So explain the DCC method for the peptide bond formation. So like that, you can get the question. Now this is acid halide. This is one method of preparation of peptide bond. And this acid halide method was given by Emil Fischer. Okay, Emil Fischer is a scientist, and more particularly, he is a father of peptide chemistry or protein chemistry. So, Emil Fischer method by converting amino acid into acid chloride. So that means it's a activation step. So for this activation step, what is required? N-protected amino acid is required. So N-protected amino, this means this N is protected by using a Z. What is Z? Z is a benzyl oxycarbonyl group. So now a benzyl oxycarbonyl group, when it is treated with amino acid, it gives N-protected amino acid. This N-protected amino acid is treated with phosphorus pentachloride. So phosphorus pentachloride is a chlorinating agent. So what it will do? It will convert OH into Cl. So the obtained one is called amino acid chloride. This amino acid chloride, what are the byproducts you can observe? HCl is one byproduct. HCl is a gas, it will go out, no problem. Whereas phosphorus oxychloride is a liquid. So this liquid retains along with the product. Then this byproduct may trouble this uh, uh, amino acid chloride. So that is the reason one can go for a other chlorinating agent. So in the next slide, I am explaining about how the other chlorinating agent converts a carboxylic acid into a chloride. So this is I am taking. Here this is the thionyl chloride. Thionyl chloride I am taking. Thionyl chloride is a chlorinating agent. So it will convert a N-protected amino acid into acid chloride. So here what are the byproduct? HCl is one byproduct. Sulfur dioxide is another byproduct. HCl is also a gas. It will go out. Sulfur dioxide is also a gas. It will go out. So what is remaining? The remaining product is pure amino acid chloride. So this method is better method compared to the previous one. So in the previous one, CCl4 used one. Okay, that is the difference you need to remember. So now a pure acid chloride is obtained. So this acid chloride is coupled with a unprotected. So this amino acid is called unprotected amino acid. This amino acid is called N-protected amino acid. So that means N-protected acid chloride is treated with unprotected amino acid. So what it will do? There will be a new bond formation between this nitrogen and this carbon. Cl and H going out. HCl is a base, it will go out. So what is obtained? The obtained one is a dipeptide. So this is about by using acid acid chloride method, it is possible to prepare a peptide. So it is a dipeptide. If you want to prepare a tripeptide, what you can do? Uh, so activation of this one means treating with thionyl chloride and treating with unprotected amino acid. So if you want to pentapeptide, activation of that and then treating with amino acid. So your this can be proceed until getting a desired peptide. So once the desired peptide is obtained, one can go for a cleavage of the N protection. Then you will get a peptide having a N terminal end free, C terminal end free one. So this is about the method of preparation of one method, that is called acid chloride method for the synthesis of peptides. So with this, I will go to the next slide. So next slide will give you the information about anhydride method. So here, more particularly, it's called NCA. NCA means N means nitrogen. This one. C means carboxy. Anhydride. This is a anhydride. N-carboxy anhydride is prepared. How the N-carboxy anhydride is prepared? By taking benzyl oxy means Z-protected amino acid. So here what is happening? You know that this is the Z. Z means benzyl group. C6H5CH2 group is called benzyl group. And this one is oxy. And this CO is called carbonyl. So benzyl oxycarbonyl amino acid. It's a Z protected amino acid. So what will happen if it is treated with PCl5? As usual, it will act as a chlorinating agent. So what it will do? It will convert this OH into Cl. So that is how the compound is obtained. So the obtained compound is heated. So that means the obtained compound is heated under vacuum. So under vacuum, I think you know the difference between the vacuum and pressure. So pressure means it will push, whereas vacuum means it will suck. Okay. Uh, what will happen here under vacuum? So when you are heating under vacuum, so there will be a new bond formation between this oxygen and this carbonyl group, and Cl will go out. So that is how a compound is obtained. The compound name is called N-carboxy anhydride. So how the N-carboxy anhydride is obtained? It is obtained by the reaction of lone pair of this oxygen to this CO. Cl is going out. So that is how N-carboxy anhydride is obtained. This N-carboxy anhydride is treated with unprotected amino acid. So I will show you in the next slide. So look here. So this is N-carboxy anhydride. So this N-carboxy anhydride is treated with unprotected amino acid. This is the unprotected amino acid. How it is reacting? The lone pair present on this nitrogen attack this carbon. Then what will happen? This bond pair will picks up this proton. So that is how a dipeptide, and also this is called a carbomic acid. This a carboxylic end is there, and this in presence of H plus, so this CO2 will go out as a carbon dioxide and forming a dipeptide. Okay. So this is about how the dipeptide is formed by employing a anhydride method. So in the anhydride method, when when benzyl oxycarbonyl carbonyl amino acid is treated with phosphorus oxychloride, it yields a N-carboxy anhydride. This N-carboxy anhydride, when it is treated with amino acid, it gives dipeptide. Okay. So this obtained dipeptide, if we are treating again with one more unit of N-carboxy amino acid, you will get a tripeptide. So once the tripeptide is obtained, if we are treating that with the N-carboxy anhydride, you will get another tetrapeptide. Like that, you can get a pentapeptide or polypeptide. So this is about what is called as how the peptide bond is formed by employing a acid chloride method and the anhydride method. Okay. So this is about what is called as how the peptide is formed by employing anhydride method and acid halide method. Okay. Uh, so what I will do, maybe I will stop at this stage. If you have any doubts, you can ask me, and the remaining I will continue in my next class. If you have a doubts, you can ask. If you don't have doubts, you can uh, log out.